Today we will study about types of redox reactions or types of redox titrations and redox curve which is obtained when we undergo a redox reaction or redox titration, and when we plot that curve on our graph. What is a redox titration? A redox reaction or oxidation reduction titration is a method of analysis that involves in changes of electrons or in valency of reacting species. In our previous lectures also, in which I taught what are redox reactions or what are redox titrations, there I taught what is a oxidation process and what is a reduction process. In oxidation process, there is an increase in positive number or decrease in electron, and in reduction process there is a decrease in positive charges and increase in electron. So, oxidation reduction titration is a method of analysis in which changes in valency or changes in number of electrons takes place. Oxidation reduction occurs simultaneously. This is the main prior condition that we cannot say कि oxidation पहले होता है और reduction बाद में होता है. Oxidation and reduction reactions is a reaction or titration in which both the reaction takes place or both are held or occur simultaneously in a reaction. One substance in the reaction, one substance gets reduced in the process of oxidizing the other one, and one substance gets oxidized in the process of reducing the other one. So, we can say that oxidation is a loss of electron or electrons, and reduction is a gain of electrons or electrons. Oxidation is always accompanied by reduction. That is why I am repeating the same thing again and again, that oxidation and reduction reactions are the reactions in which both the reaction occur simultaneously or hand in hand, both are complementary to each other, both are being complementary to each other. If one of the reaction is stopped, then other one will automatically get stopped by itself. Oxidizing agent or oxidant oxidize the other component of the reaction and themselves get reduced, while reducing agent or reductants reduce the other component. That is why they are called reducing agents and are themselves get oxidized. So, now in this lecture we will study about this was all about the redox titrations and redox reactions. Today's lecture we will study about redox types of redox titrations. There are various types of reaction which involve this redox fundamental in their chemical processes. What are those reactions? Type of redox titrations are named according to the titrant which are being used or according to the reacting species which are being used. जो भी type of titrant हैं या type of reactant हैं जो आपके redox reaction में participate कर रहे हैं, उनके हिसाब से हम लोग decide करते हैं कि what are the types of redox titration. So, first type is bromometry or bromatometry which uses bromine as titrant. Next is cerimetry which uses cerium salts as titrant. Then is dichrometry which uses potassium dichromate as titrant. Iodometry and iodometry which uses iodine or its some of the salt like potassium iodate, potassium iodide, some of its salt of iodine as titrant, and last but not least permagnetometry which uses potassium permanganate as titrant. So, among these two titrations are very common and which are usually held in laboratories. These two titrations are very common and this one also. So, all of us have various performed this permagnetometry titration and iodometry titration in our practical laboratories also. So, these were the types of redox reactions or redox titrations. Then what is oxidizing agent? As I have told you earlier, oxidizing agent. What is a agent first? Agent is a person which does something for others. Okay? जो दूसरों के काम करते हैं, इसीलिए ऑक्सीडाइजिंग एजेंट एक ऐसे एजेंट होते हैं जो दूसरों को ऑक्सीडेशन करते हैं. तो अगर एक रिएक्शन में ऑक्सीडेशन और रिडक्शन दो प्रोसेस हो रही हैं, तो अगर एक रिएक्टेंट दूसरे का ऑक्सीडेशन कर रहा है तो इट मीन्स वो अपना रिडक्शन कर रहा है. इट्स वेरी क्लियर. ओके. और इसी तरीके से रिड्यूसिंग एजेंट अगर दूसरों का रिडक्शन कर रहा है दैट मीन्स वो अपना ऑक्सीडेशन कर रहा है, क्योंकि दो ही प्रोसेस हैं जो पूरे रिएक्शन में हो रही हैं और पूरे रिएक्शन को गवर्न कर रही हैं. So oxidizing agent is a agent or oxidant, we can call it as oxidant also, oxidizer also, is a substance that has the ability to oxidize other substances and themselves get reduced by gaining electrons. This definition is very important and mentions all in itself. जो भी अभी तक मैंने आपको बताया वो समराइज फॉर्म में ये डेफिनेशन आपको सब कुछ बता रही है कि ऑक्सीडाइजिंग एजेंट आर द एजेंट्स और ऑक्सीडेंट और ऑक्सीडाइजर which has the ability to oxidize the other substance or other reactant and themselves get reduced by gaining the electron. अपना रिडक्शन करते हैं इलेक्ट्रॉन्स को गेन करके और दूसरों का ऑक्सीडेशन करते हैं. कॉमन ऑक्सीडाइजिंग एजेंट्स आर ऑक्सीजन, हाइड्रोजन peroxide, halogens, permanganate, chromate, osmium tetroxide and perchlorate also. Now moving ahead, reducing agents. Reducing agents, which are also called as reductant or reducer, is an element or a species or a compound that loses or donates electron, that loses or donates electrons in itself and themselves get oxidized and reduces the other component. अपने आप को ऑक्सीडाइज करता है और दूसरे कंपोनेंट को रिड्यूस करता है, इसी वजह से हम उसे रिड्यूसिंग एजेंट बोल रहे हैं. इज एन इलेक्ट्रॉन टू अनदर केमिकल स्पीसीज इन अ रिडॉक्स केमिकल रिएक्शन. सिंस द रिड्यूसिंग एजेंट इज लूजिंग इलेक्ट्रॉन इन इटसेल्फ, सो इट इज सेड टू बी गेटिंग ऑक्सीडाइज्ड एंड द अदर कंपोनेंट है दैट इज अंडरगोइंग रिडक्शन, दैट इज सेड टू बी getting reduced and the reducing agent is getting oxidized. Okay, is it clear till now? I hope it is clear till now. Examples of reducing agents include alkali metals, alkaline earth metals और जितने भी most of the metals हैं वो सारे आपके reducing agent में आएंगे, क्योंकि वो अपना खुद का self oxidation करते हैं और वो खुद oxidation undergo करते हैं और दूसरे species का reduction करते हैं. And metals and alkaline earth metals. Then redox potential. Redox potential, also known as oxidation reduction potential, is a measure. And now what is redox potential? Redox potential जैसे कि आपने आपके acid base titration में आप लोग pH measure करते हैं to monitor a reaction. In redox titration we measure a redox potential or oxidation potential of the particular reaction to monitor the reaction. Redox potential, also known as oxidation reduction potential, is a measure of tendency of a chemical species to donate or gain electrons, thereby getting oxidized and reduced respectively. So redox potential या oxidation reduction potential क्या होता है? Oxidation reduction potential या redox potential is measure, एक measurement है कि आपका रिएक्शन में कितना हद तक, कितना लिमिट तक ऑक्सीडेशन हो गया है और कितना लिमिट तक, कितनी कैपेबिलिटी तक रिडक्शन हो गया है. इज ए मेजर ऑफ टेंडेंसी ऑफ द रिएक्टिंग केमिकल स्पीसीज. जो भी दो रिएक्टेंट हैं, जो भी दो रिएक्टिंग स्पीसीज हैं आपस में जब रिएक्ट कर रहे हैं, ऑक्सीडेशन रिडक्शन कर रहे हैं, तो उनका जो रिएक्शन है वो कितना सक्सेसफुली हो रहा है, कितने लिमिट तक आपका ऑक्सीडेशन एग्जिबिट हो रहा है और कितने लिमिट तक आपका रिडक्शन एग्जिबिट हो रहा है. ठीक है, जो भी केमिकल रिएक्शंस हैं या केमिकल स्पीसीज हैं उनकी जो कैपेसिटी है या कैपेबिलिटी है टू डोनेट और गेन इलेक्ट्रॉन्स एंड देयर बाय गेटिंग ऑक्सीडाइज्ड एंड रिड्यूस्ड, उन सब चीज़ों को आप गवर्न करते हैं, मॉनिटर करते हैं रिडॉक्स पोटेंशियल से या फिर ऑक्सीडेशन रिडक्शन पोटेंशियल से. ओके, सो ऑक्सीडेशन रिडक्शन पोटेंशियल इज ए वेरी वेल अकाउंटेबल पैरामीटर फॉर गवर्निंग ए रिडॉक्स रिएक्शन और रिडॉक्स टाइट्रेशन. हम उससे गवर्न कर सकते हैं कि कौन सा जो आपका रिएक्टेंट है वो कितना ऑक्सीडाइज हो चुका है और कौन सा जो रिडक्टेंट है वो आपका जो रिएक्टेंट है वो कितना रिड्यूस हो चुका है. सो रिडॉक्स पोटेंशियल इट इज मेजर्ड इन वोल्ट्स और मिली वोल्ट्स. ईच स्पीसीज हैज़ इट्स ओन रिडॉक्स पोटेंशियल विच शोज, और वो डिपेंड करता है उसकी एफिनिटी टुवर्ड्स द इलेक्ट्रॉन। उसकी जो एफिनिटी, उसका जो टेंडेंसी है, नेचर है इलेक्ट्रॉन्स को गेन करने का या लूज करने का, उस पर डिपेंड करता है आपका रिडॉक्स पोटेंशियल या फिर पूरे रिएक्शन की इंट्रिंसिक रिडॉक्स रिएक्शन पोटेंशियल। देन Nernst equation. Nernst equation is none other than a parameter or equation which relates the electrode potential or relates the redox potential to the number of ions. It is an equation that relates the reduction potential of a electrochemical reaction to the standard potential, temperature and activities. Activities means concentration of the species or reacting species which are undergoing the reaction, which are undergoing the oxidation and reduction. It was named after Walther Nernst, a German physical chemist who formulated this particular equation. So, Nernst equation is a equation which correlates the electrode potential with the concentration of the reacting species, temperature, electrode potential, and it was named after a German scientist जिसका नाम था Walther Nernst. So, what is that equation? Let us study it. This is the equation. Here you can see this is the electrode potential. This is the standard electrode potential E0. Then R is the gas constant, F is the Faraday constant, T is the absolute temperature, and N is the number of electrons gained by a oxidant in being converted to a reducing agent. N is the number of changes in electron or number of electron gained or loosed in a reaction. So, that is Nernst equation. Then comes equivalent weight. What is the equivalent weight of oxidant and reductant? I have already covered equivalent weight and how to calculate equivalent weight of a reductant and oxidant or oxidizing agent or reducing agent in our previous introductory lecture of redox titration also. So, what is equivalent weight of a reducing agent and oxidizing agent and how do we calculate it? Equivalent weight of a reductant or oxidant is equal to the molecular weight of oxidant and reductant divided duly by the changes in number of electrons or changes in the valency of reacting species or changes in the number of electrons per molecule. एक मॉलिक्यूल कितने इलेक्ट्रॉन गेन कर रहा है या कितने इलेक्ट्रॉन लूज कर रहा है, एक मॉलिक्यूल रिएक्टिंग स्पीसीज का, एक मॉलिक्यूल ऑक्सीडेंट का या फिर एक मॉलिक्यूल रिडक्टेंट का कितने नंबर ऑफ इलेक्ट्रॉन गेन कर रहा है या फिर लूज कर रहा है रिएक्शन में, दैट इज द चेंजेस इन नंबर ऑफ इलेक्ट्रॉन पर molecule. ये per molecule is very important thing which is need to be taken care of. Equivalent weight is equal to the molecular weight of reductant and oxidant and divided by the changes in number of electrons per molecule of reductant or oxidant for whomsoever you are calculating the equivalent weight. अगर आप ऑक्सीडेंट का कैलकुलेट कर रहे हैं तो उसका मॉलिकुलर वेट मेंशन करेंगे, अगर आप रिडक्टेंट का कैलकुलेट कर रहे हैं तो आप उसका मॉलिकुलर वेट मेंशन करेंगे देयरइन. सो मूविंग अहेड वी कम टू रिडॉक्स कर्व और a redox titration curve. A redox curve is a oxidation reduction titration curve. In similar way, in acid base titration, titration curve is plotted in terms of pH versus the concentration of a standard solution which is undergoing the titration such as alkali or acid respectively. Whereas, in redox titration or redox reaction, the curves are plotted in terms of oxidation potential versus the percent titration of the solution. कितना titration आपका complete होता जा रहा है, कितना reaction versus the oxidation potential, इन दोनों के बीच में जब आप ग्राफ प्लॉट करते हैं, कर्व प्लॉट करते हैं, then that particular curve is known as redox curve or oxidation reduction curve. In redox titration, the concentration of redox ions involved in the reaction continuously keeps changing throughout the reaction in the course of titration or during the course of titration. We very well know कि जब आपके रिडॉक्स टाइट्रेशन होते हैं या रिडॉक्स रिएक्शन होते हैं, जब भी आप टाइट्रेशन स्टार्ट करेंगे तो ड्यूरिंग द प्रोसेस ऑफ टाइट्रेशन आपका जो नंबर ऑफ रिएक्टिंग स्पीसीज है, कंसंट्रेशन ऑफ रिएक्टिंग स्पीसीज है, वो चेंज होगी कंटिन्यूसली. जो आपका रिडॉक्स पोटेंशियल है, बिकॉज ऑफ दैट कंटिन्यूसली जो रिडॉक्स पोटेंशियल है दैट विल कीप changing during the course of titration. Hence the redox potential of the solution keeps on changing all through the titration. जो भी oxidation potential या redox potential है आपके reaction का, that will continuously change, that will keep on changing throughout the reaction जब तक आपका end point achieve नहीं हो जाता. Similar to the changes in the pH of the solution in acid base titration. जैसे acid base titration में आपके pH changes होते थे, in the similar way here redox potential or oxidation potential keeps on changing with the changes in the valency of oxidant and reductant. So by plotting the redox potential corresponding to the different points, अगर आप different points of reaction पे redox potential या oxidation potential को plot करेंगे, then we will get a beautiful graph of oxidation reduction, curve of oxidation reduction potential of a particular reaction. Redox curve is similar to the curve obtained in acid base titration. And how does it appear? तो redox curve में आप यहाँ पे देखिए आपका, दिस कैन बी इलिस्ट्रेटेड बाय कंप्यूटिंग द टाइट्रेशन. अब हम लोग इसको इलिस्ट्रेट कर सकते हैं वेरी वेल विद द हेल्प ऑफ अ रिएक्शन और अ एग्जाम्पल ऑफ टाइट्रेशन. टाइट्रेशन बिटवीन आयरन एंड सीरियम. 0.1 molar of iron in +2 state or ferrous state is reacting with 0.1 molar of cerium in steric state. So this is undergoing oxidation and this is undergoing reduction, as we have earlier seen also. So यहाँ पर आप देख रहे हैं कि ये दोनों के बीच में रिएक्शन होगी. This can be represented by Nernst equation as follows. So redox curve can be computed and calculated by plotting a curve between the volume of titrant or percentage of reaction which is being covered or which is being completed against the electrode potential or redox potential. Then redox curve has different regions, as we can see very well. First region is the initial region. It is the point at which titration starts up and proceeds slowly, very slowly. जो यहाँ पे आपको दिख रहा है कि यहाँ पे आपका जो प्लॉट है वो बहुत धीरे धीरे बढ़ रहा है and the slope is very horizontal. Okay, स्लोप आपका बहुत हॉरिजॉन्टल, इट्स नॉट एट ऑल स्टीप, इट्स नॉट एट ऑल वर्टिकल. इसी से हम पता कर सकते हैं कि जो परसेंटेज ऑफ रिएक्शन है वो बहुत स्लोली आपकी इंक्रीज हो रही है. दो नेक्स्ट कम्स द बफरिंग रीजन. इट इज अ रीजन इन विच द रिड्यूसिंग एजेंट टेक्स ए स्मॉल अमाउंट ऑफ टाइम टू लूज द इलेक्ट्रॉन. ये बफरिंग रीजन है जिसमें इलेक्ट्रॉन्स gain and lose of electrons gets buffer up. Okay, then next is equivalence point. When the titration proceeds, then suddenly आपका equivalence point achieve हो जाता है. This is the equivalence point जहाँ पे आपके जो reductant है या reducing agent है is equivalent to oxidant. Okay, so this is the equivalence point. You can very well see from the graph. Equivalence point is a region where the concentration of oxidized and reduced ion are just equivalent to each other. At this point, there is a sharp and sudden rise in the curve till the end point is achieved. Then after equivalence point comes the inflection point. It is a point on which tangent crosses the curve itself on the point at which the curvature changes and the reaction again becomes horizontal and the reaction again becomes very slow because our end point is already being achieved and there is no more sudden changes in the concentration of oxidant and reductant. Then over titration, it is the region showing the constant potential and the indicator stops changing its color and remains very stable. This is the end of the reaction. So now we come to the end of type of redox titration. So we saw there are various types of redox titrations: chromatometry, serimetry, permagnometry, iodimetry, iodometry. Okay, and so according to how these types of redox titrations were decided, according to the type of oxidant and type of reductant which are used in the following reaction, we were deciding the type of oxidation reduction reaction. So, on the same basis there are various applications of oxidation reduction reaction between analyte and titrant. So, there are various applications of redox reactions or redox titrations. They can be very well applied in chemistry, biology, environmental sciences, material sciences, where various analytes can be determined and can be measured as behaving as oxidant or reductant, such as purifying metals, producing pure gases or purification of gases, electroplating of metals, which you have already studied at your school level, protecting metals from corrosion, that can be also done with electroplating. Then with the help of redox titration, balancing complete equations also can be done when we plot the graph of a redox reaction or a redox titration. So, this was all about types of redox titrations and its application, how to plot a redox curve, how far it is important in monitoring a redox titration or redox reaction, what is an oxidant reductant and how to calculate the equivalent weight of oxidant and reductant. So, this was the gist and summary of types of redox titrations and redox curve which we have seen in this lecture. I hope it was beneficial to every one of you. So, now we will summarize what are redox titrations and what are its type. So, redox titrations are the titration methods of analysis which involve the changes in the valency of reacting species or changes in the number of electrons of reacting species. Oxidation is always a loss of electron and reduction is always a gain of electron. Oxidation, this is the important thing which is to be monitored, that oxidation and reduction always happens simultaneously or always goes hand in hand. अगर वहाँ पे कोई ऑक्सीडेशन नहीं है तो रिडक्शन भी नहीं होगा, ठीक है. ऑक्सीडेशन इज ऑलवेज अकम्पनीड बाय रिडक्शन and reduction is always accompanied by a oxidation. Oxidizing agent or oxidants are the agents which oxidizes the other component or other reactant and itself get reduced, and reductant are the reagents or the reductants are the reacting species which reduces the other ones and itself gets oxidized. So, types of reducing आपके redox titrations में I told you what are the types of redox titrations and it depends upon the type of reductant which are used. आपके जो भी reacting species हैं, ठीक है, जो भी आपके titrant हैं उसके हिसाब से types of redox titration, कई सारे redox titration हो सकते हैं जहाँ पर भी आपका जो governing reaction है that is redox reaction, वहाँ पे आप redox titration उसे बोलेंगे. और redox titration के कई types हो सकते हैं, डिपेंड करता है कि आप किस एनालाइट का डिटर्मिनेशन कर रहे हैं या कौन सा टाइट्रेंट उसमें पार्टिसिपेट कर रहा है. फॉर एग्जाम्पल ब्रोमोमेट्री और ब्रोमैटोमेट्री, सेरीमेट्री, डाइक्रोमेट्री, आइडोमेट्री और आयोडोमेट्री. आयोडीमेट्री में वी यूज़ आयोडीन एज ए स्टैंडर्ड सोल्यूशन, आयोडीन सोल्यूशन, एंड आयोडोमेट्री में हम आयोडीन का एक सॉल्ट सच एज पोटेशियम आयोडेट वी यूज़ इट एज ए रिएजेंट. देन परमैग्नेटोमेट्री में हम पोटेशियम परमैग्नेट यूज़ करते हैं, ब्रोमैटोमेट्री में हम ब्रोमीन यूज़ करते हैं. ओके, सेरीमेट्री में हम सेरिक सॉल्ट्स यूज़ करते हैं जो कि आपको रिएक्शन में मैंने लास्ट आपके लेक्चर में एंड प्रीवियस लेक्चर में और इस लेक्चर में भी आपको बताया कि सेरिक सॉल्ट जो होते हैं वो सेरस में कन्वर्ट हो जाते हैं. ओके, दे आर गेटिंग रिड्यूस्ड और जो आपका फेरस है वो फेरिक में कन्वर्ट हो रहा है एंड दैट इज गेटिंग ऑक्सीडाइज. तो सेरीमेट्री का जो टाइट्रेशन है वो ज़्यादातर मोस्ट ऑफ द टाइम आयरन के साथ होता है. तो दीज आर द टाइप्स ऑफ रिडॉक्स रिएक्शंस And what is oxidizing agent, reducing agent? Oxidizing reducing agent are the agents which oxidizes the other one and itself get reduced, and reducing agent are the agents which reduces the other one and itself get oxidized. Redox potential is a governing oxidation reduction potential which governs the whole redox reaction, which governs the changes of electron throughout the reaction, and when it is plotted according to the Nernst equation, when it is plotted against a graph, then we come to know a redox curve. When we get to know a redox curve, which I have shown here, a redox curve is a curve between the volume of titrant which is added from the burette and the redox potential or oxidation potential. So, when we monitor a reaction, when we monitor a redox reaction with the help of a redox curve, by monitoring the electrode potential or redox potential of that particular reaction, then we will get to know this particular curve which is sigmoid shape curve. This is sigmoid in shape, and sigmoid shape curve के आपके different आपके parts हैं, initial region, buffering region, equivalence point, and after that inflection point and over titration. These are the application of redox titration, and that is all students for types of redox titration, curve and application. I hope this was helpful for you all. Thank you all. Thank you everyone.